I want to bring my chat up first because someone else texts something. It's only $1 though. A shower curtain's only $1. Okay. So for the project, let's see, this class is 20. And so you go down to, well, you can actually click here for homeworks, and it's hmm, scatter plot homework for the project. Oh yeah, right here. Scatter plot project due. And so when you click on it, it should be there. Hmm. Some people turned it in, but I don't see it on there. Oh, here it is down here. So when you go into it, no, that's the homework. Where's the,
Yeah, I didn't see the questions on for the project.
oh my gosh, I don't know. All right, let me bring it up. I cannot believe nobody else mentioned it. I must have it up in my other classes then because they didn't say anything. 620. Oh, this is 15, 10:30. Okay, so I will make sure this gets put up today. I'm sorry about that. Um, so you want to gather 25 pairs of data. And when you're gathering it, if your um, other, what you had sent in for the homework, if it's just not working the way you want it to and you want to change it, that's fine. You don't have to ask me, or if you want to ask me if it'll work, that's fine. But you can change. Enter the data in 2 columns. It's up to you if you use Excel, Desmos, TI-84, or any other means that will get you a scatter plot, a trend line, and an R squared.
Okay, and you told me that I have to did you say that I have to label each Y point?
No, you don't need to label them.
Like
You
as in
do
like
have to find like the trend line and the trend. Okay, so you graph your scatter plot, you find the trend line and R squared. Make sure your independent is on the x-axis and the dependent is the y. So if we were doing size of tattoo and the price, the size of the tattoo would be the x-axis because it causes the price to go up. Um, and then this is the paragraph you write. How you gathered your data and why you chose it. What you thought the outcome would be and what it was looking for. So they were student who did the tattoo one thought the bigger the tattoo, the higher the price. And that's what she was looking to see because she was interested on a tattoo on her back. Explain the slope and the y-intercept. That's on your trend line. Remember the slope as x increases by 1. So as the tattoo increases by 1, say, centimeter, the cost might go up um, by $1. I don't know. I don't remember what her values were. The y-intercept is wouldn't necessarily make sense because that's when the size is 0 uh, and the cost, whatever the starting cost was. But there might
um
be a fixed cost like for the needle and things like that.
so the one what I chose, the data that I chose was the the length of each song
Okay.
and the tempo for each song. So would the tempo be X and the length of the song be Y?
Okay, so you were testing if as the tempo increased, the song got longer.
Uh, yeah.
Okay, so then the tempo would be the X. If you
Okay.
thought the longer songs had more tempo, then you'd switch it. So that
I
one's
mean, I have I have it written down as like points, but it looks like it just varies.
And that can be. Then the same thing happened with the tattoo because, of course, the price of the tattoo is not just the size. There's so many other things, detail, how many different colors of ink. And so the same thing with this, it's just something that varies. You thought there would be a relationship, which is fine, but then there wasn't as much as you thought. And then you just explain that.
Like so it would make sense. So like it would be all right if I had like over 5 minute long song with a 73 meters per second or meters per second minutes per second.
Mm-hmm.
Wait, yeah. So yeah, like it would be like a long song with a short like a 73 BPM tempo,
Yeah,
like
that would be
like a really
fine.
slow tempo but a long song, or
Mhm.
like it wouldn't matter.
Right.
Okay.
Yeah, no, that's fine. It your data was probably spread all over when you graphed it.
When I graphed it, it was um. Hold on, I need to look at it again. So when I graphed it, it's kind of like it's kind of scattered, but it's mainly a straight line, like a
Okay.
horizontal line.
Almost horizontal. So your R squared was probably 0.
Yeah.
Yeah. So there's not a strong relationship on your tempo and how long a song is. It deals with other things. And that would just be your explanation, which is fine. So since your R squared was 0 or is close to 0, there wasn't as strong a relationship as you thought there would be.
Okay.
Yep,
Thank you.
that's fine. You're welcome. Yeah, I'm sorry. I did not realize I must not have attached it. Um, if you, I don't, I don't know if anyone's turned it in. If you already turned it in and you didn't have these questions, you can still turn it in. Uh, just write the paragraph and add to it. Is there any other questions on it? So even if you thought it was a strong relationship and it ends up not being it, it doesn't mean start something else. Just explain that there wasn't. Any questions? I'm sorry about that, though. I thought that was up there. Is there any questions? You'll probably receive an email. I'll send an email with this so those who aren't here know. Now I understand some of the questions I was getting. Any questions? Okay. Um, Chapter 6 deals with limits and then the long form of the derivative. And so the first thing we're going to start with is looking at limits from the right and the left. If we had this equation, when we first look at this, what value can x not equal? So what needs to be omitted from the domain? Anyone? I was going to say. Remember, when we find the domain and you have a fraction, you have to set the denominator equal to 0. And then solve. If we add the 2 to the other side, we get x equals 2. So 2 will give us 0 in the denominator. It needs to be omitted. Any questions on that?
Problem 1 started with is problem 1 just the f of x equals and then the fraction?
Mm-hmm. Yeah.
Okay.
So if we had this problem, we know that x cannot be 2. So one thing we could do is find out what happens from the right and the left. As we get close to 2, what happens? And so one way of doing that is plugging in values. So we'll do this one first. Now, one way of plugging in values, you can just take 2.1, because that's close to 2, but a little bit larger, and plug it in. 2.1 squared minus 4 over 2.1 minus 2. And then you plug the next one in and the next one in. Anytime you have to keep plugging the same value in, you could use your calculator. Desmos would probably work also, or you just plug them in. We probably wouldn't do a problem where we have to plug all of these in, but there are cases where we have to plug a couple values in when we do the derivatives. Excuse me. So we want to plug 2.1 in here, then 2.01, and so on. One way of doing that, if you use your calculator, is to go under y equals and plug it in here, which, let's see, let's clear that one. It's x squared minus 4. If you do not have a fraction bar, you have to put your top and bottom in parentheses. You don't need to graph it, so the window doesn't matter. You just go to table, and then you can plug values in. 2.1, 2.01, 2.001. And it'll give you the values. Now, if you plugged these in here and worked it out, you're going to get the same answers. Notice as this gets closer and closer to 2, this gets closer and closer to 4. Any questions on the plugging in part?
My calculator didn't bring up like 2.1, 2.01. Like whenever I went to the table, it just put in like 1,
Okay.
2, 3, 4.
So if it's putting in numbers automatically, we want to use this blue, see the table set? So hit second in table set. And what's happening is the auto is highlighted. So if your calculator is automatically putting values and won't let you type in the table, you go to table set and then go down. I hit clear. Oops, wait a second. Second table set. So what's happening is it looks like this. What you want to do is make the independent variable and only the independent ask. That way it wants you to enter it instead of doing it automatically.
Okay, I got it.
Good. So then go back to your table and it should let you plug those in. You type the number and then hit enter. So as this is getting closer and closer to 2 from the right, it's a little larger. This is getting closer and closer to 4. Now when you write that limit, this little plus sign means from the right, a little bit larger than 2. And as we are coming close to 2, the y value is getting close to 4. So this is always your y value. And this is from the left. So that little plus sign above the 2 means from the left. Any questions on that part? So we know from the left it's getting close to 4. What's happening from the right? A little bit smaller than 2. Well, a little bit smaller would be 1.9, 1.99. Notice these are on the left side. So we're coming from the left and we're getting closer and closer and closer to 2. So this little minus sign means from the left. And we usually use from the right and from the left when it can't exist at that value, because we can't just plug in 2, then we'll get 0 in the denominator. So if you go back and then plug these values in, 1.9, 1.99, we're getting 3.9, 3.99, we're getting closer and closer to 4. So as this gets close to 2 from the left, this gets close to 4. So when you're asked for a limit of a value that doesn't exist, you can plug values a little bit larger and a little bit smaller and see if they come into the same value. Are there any questions on that? Well, there's 2 theorems. If the limit as x approaches a equals a certain value, and the limit as x approaches a, notice this one's from the right and this one's from the left. If they both equal the same value, then the limit as x approaches a is that same value. So if we're coming in from the right and the left at the same value, then our limit at that value is the same number. It's a little easier once we see the graphs to understand.
Wait, so plus, when it's x to the 2 and then a plus, that means from the left?
From the, oops, I think I said right, but I wrote left. From the right. Sorry about that.
So plus is right and minus is left.
Yes.
Okay.
Think of the number line. If the plus sign means a little larger, so it's on the right. The minus means a little smaller, so it's on the left. So I think looking at the number line helps. So make sure you put right on this if you. Now when these two are equal from the left and from the right, then at that value, it's the same limit. If they're not equal, then the limit at that value does not exist. So DNE means does not exist. Going back to the problem then, we want to find the limit as x approaches 2. So from the right, it's 4, and from the left, it's 4. Since these two are the same, then the limit at 2 is 4. So that means from the right and the left, it's coming into the same value at 2. The y value is 4. Even though f of 2 does not exist because it gives us 0 in the denominator. So whether the actual point exists or not doesn't matter. You just look at the limit from the right and from the left. Here's an example. We look at this first one. Now this is chapter 11. This was an old book, but I like it because it had sheets instead of put together. But it's the same problems. If the limit approaches 2 from the left is 5 and from the right is 6, they want us to find the limit at 2. Now, because these two are not equal, this one doesn't exist. So they have to both be equal or it doesn't exist. Any questions on that? The second one, they're saying the limit as x approaches 2 from the left is equal to the limit as x approaches 2 from the right, and that value is a -1. So these two are equal. But then it's saying f of 2 is 1. So they want us to find the limit as x approaches 2. As long as these two are the same value, this one will also be that value. So it will be -1, not the +1. So if your limit from the left and the right is the same, the limit at that value is also the same, -1. Doesn't matter what this is. Any questions on that? Any questions so far? Okay, let's look at some of the graphs. Let's look at number 7. I should erase my answers. Now to combine 6.2 and 6.1, the only thing 6.2 does is it adds continuousness, whether it's continuous or not. Like the first problem we did, it's discontinuous at 2 because 2 gives us 0 in the denominator. So this would be discontinuous. X equals 2. So anything omitted from the domain, that's where your function would be discontinuous. Now, if we looked at number 7, how well you can see the graph. Oh, that's a lot better. There we go. So there's an open circle right here and right here. Now to see where it's discontinuous or what you do is you trace. And if you have to lift up your pencil, that X value is where it's discontinuous. So if I'm tracing this right here, I'm going to lift up because there's an open circle that points up here instead. So it's discontinuous at 0. And then when I trace some more, there's a jump here in the line. And that's at 2. So you always use the X values. But wherever there's a jump in the graph, that's where it's discontinuous. So this one's discontinuous at 0 and 2. And then that's why you look for limits at those areas. Is there any questions on that? Okay. Now, if we look, this one, since it's discontinuous, I always have you find limits from the right and the left. So I would find for the 0, the limit as x approaches 0 from the right, limit as x approaches 0 from the left. So on a test, I would give you all 4 of these. Now, looking at the limit as x approaches 0 from the right. Look at this line, the axis from the right means a little larger. So go a little bit larger than 0, and notice we're coming in here at the origin. So the y value is also 0. So as x is getting close to 0, so is y, because it's getting close to the origin. Right here. The other one is saying from the left, a little bit smaller. So as I'm getting close to 0, if I go on the left side of the line, I'm over here. But I'm still getting close to the origin where the y value is 0. And when those two sides come into the same value, that's when these two will be equal. And that's when this one will be the same value. Because if from the right and the left is equal, this one equals the same. And in most cases, you would look for this first. If it's not coming in from both ends, then you would look at these to see what it is doing.
How do you know that the positive and negative ones are 0?
So what you want to do, this positive one, you want to see where it's coming in at the y value. So as I'm tracing my graph, as I get close to x being 0, because it's a 0, the y is also 0. So you're looking at this point and taking the y value. And you're coming in, both sides are coming into the same point, the point 0, 0. This is the y value.
Okay.
I think it'll help more when we do the next one also. This last part is a shaded in point. Now, if there isn't a shaded in point, if you look at the one above here, notice there's an open circle. So f of 2 here would not exist because there's no colored in point. Where this one, there is. It's right here at 2. 1, 2. So this f of 0 is looking for the point where x is 0. And that would be this point. The point is 0, 2. So your answer would be the y value. All of these answers would always be your y value. So our shaded in point is the point 0, 2. X is 0, y is 2. Any questions on that part? Let's try. The limit as x approaches 2. To find the limit as x approaches 2 from the right, the limit as x approaches 2 from the left, the limit as x approaches 2, and f of 2. Now, if you want, what some students do, this one, it had a line already drawn on the axis, but if you want to draw a dotted line through it, that way then when you're thinking of to the right and the left, you go to the right of the line and the left of the line. It's a little easier to see which line you're using. Because notice the difference. This one's coming in at two different values or two different areas, where this one came through the same on the right and the left. When it came in the same on both sides, that's when we had all our values the same. Since this one is coming in at two different points, these are not going to be the same. By finding that break, that's where certain items either increase or drop in price. And we'll do a lot of problems like that. So in this case, the first one is from the right, plus a little bit larger. So if I go to the right of the two, notice I'm here. Because this line's here, I wouldn't be over here because there's no line down here. It's up here. And the point it's going to is the point 2, 1. We want the y value 1. So we went to the right because of the plus on the 2. And our point or our graph is up here. So as we're getting close to 2, y is getting close to 1. Any questions on that part? So then this one is a little bit smaller, or on the left side. So start at 2 and go a little bit smaller, or on the left. My graph's down here. There's no graph over here on this side of the line. It's down here. And so it's getting close to this point, the point 2, -2, and you use the y value, so it's -2. Any questions? So on the right, our graph went to this point, which the y value was 1, and from the left, it went to this one, which was a -2. By that theorem, these two are not equal, so this one does not exist. Since we're coming in at two different spots. Any questions on that? F of 2 is the shaded point, and this one has an open circle, but this one has a shaded point, and so it's 2, -2. So when x is 2, y is -2. We'll try another one, but is there any questions on that one? So number 8, first thing we want to do is see where it's discontinuous. Looking at 8, what two values does it discontinue, or not two values, not necessarily. What value of x is it discontinuous? Anyone? You can type it in if you don't want to say. Trace the line, and wherever there's a break, you use that x value. 5, yes. So if we traced it, there's a bend here, but this is still shaded in, so it's still continuous there. But when we hit here, we have a jump. And this x value is 5. So wherever there's a break, it's discontinuous at that value. And so that's all 6.2 does, is it adds that part to it. So then it says, where's it discontinuous, and then has you find the same things. Now, since even though it's not discontinuous, we'll find the limit at 3 since it's asking for it here. Notice from the right and the left, it's the same value. Whenever you have a solid line where there's no break in it, the limit's going to be at that value. So the limit from the right and the left is both going to 2. I'll write it out. So if you're looking at a solid point where it's colored in and continuous, these will all be the same. Now, if there's an open circle like this one, then 1 or 2 might be different, or here. But if it's a solid line, then these will all be the same. Because if we look from the right, we're at 3, and we're at the point 3, 2, so the y value is 2. On the left side, we're also at the same point, 3, 2, so the y value is 2. Since these two are equal, this one is the same. And the last one is the shaded point. And if we look at the shaded in point, it's the point 3, 2. When x is 3, the y value is 2. So if you have an area with the shaded in or a continuous line, these will all be the same. For the most part, I would be asking you where they are different, because for a business aspect, you want to find those breaks. Like if you're buying even pencils, when you're buying groups of them, when you hit a certain amount, the price drops. And so you want to find that break in that continuous line. So then that's where your sales are. Or if there's a jump, then you want to go up to it, but not past it, because then there's a big increase. And so you look for those things in your business classes. Any questions so far? So let's find the limit from the right and the left at the 5, where it is discontinuous, where we should have different answers. We'll find the limit as x approaches 5 from the right. Limit as x approaches 5 from the left. Limit at 5. And f of 5. So go ahead and find those. So the limit as x approaches 5 from the right. Does anyone want to say what they got?
Is it 3?
Mm-hmm. Exactly. Nice. Also, it looks a lot easier when I'm doing it in class. When you go home by yourself, sometimes it doesn't look as simple. So if you have questions, just send me pictures. But yes, from the right would be on this side. And so it would be 3. How about limit as x approaches 5 from the left? Anyone? And you could type it in the chat if you don't want to say.
Is it still 3?
I'm sorry, I couldn't hear you.
It's still 3.
No.
Is it -2?
Yes. The reason it's -2, we want to go to the left. And so that would be over here, which brings us down here at the -2. And so this one's going up to 3, but this left side is going down to -2. And you will use those points. But so it would be -2. Is there any questions on that? Since these two are not equal, this one does not exist. Any questions on that? We know these two would be different because if you notice the line from both sides, they're not coming in the same spot. Where this one came in at the same spot, these two are not. Any questions on that? How about f of 5? What does it equal?
-2.
Because you're looking for the shaded in point. This one's an open circle, but this one's solid. So it does exist and the y value is -2. Any questions on that? I think there's one on the homework on my labs that looks like this graph. Oh, wait, infinity. But is there any questions on the limits to a value using the graph? This one is asking us to find the limit as x approaches infinity. What they're talking about that is x is getting large, so we're going this way. We want to see if the graph is reaching a value or keeps going up or down. In this case, as x is getting large, if we trace our graph, it's approaching this horizontal asymptote. So it's approaching 3. That means there's a bound on it, and it's 3. So your limit is looking what it approaches. And this one, as x is getting large, we have a bound on it, we're approaching 3. If we look at the limit as x approaches negative infinity, as this is getting negatively large, this graph has an arrow. It keeps going down, down, down. It's getting negatively large. So as we're going down, because negative infinity would go this way, the points are going down, then this is going to negative infinity. That means the values are getting negatively large. There's no bound on it. So it actually does not exist. There's no limit. Now, when that happens, we still want to find out which way the graph's going. So this tells us it's getting negatively large. When something doesn't exist, in this case, then it would also ask you to put positive or negative infinity. So it will ask for both. Any questions on that? So since there's no bound on it, it's negatively large. The limit actually does not exist. And you can see I already wrote the answer on this one. If we look at this one, it's asking for the limit as x approaches negative infinity. So as x is getting this, remember this is your x-axis. As x is getting negatively large, so is my y value because it's going up. And that's why it's positive infinity. which means the limit doesn't exist. There's no bound on it because the number's getting positively large. So it will ask for both. It will say if the limit doesn't exist, is it approaching positive or negative infinity? Is how it would be written on a test. And that's probably how MyLab has it written too. Okay, so find the limit as x approaches positive infinity. So we're going positive infinity for x. Notice y is also going up. So the limit does not exist because it's approaching positive infinity. Because they're both going up, they're both going to be positive infinity. Any questions on that? Okay, number 15. Use the table of values to estimate the limit as x approaches 1. If we look as we're approaching 1, notice 0.9, 0.99, kind of like the numbers we typed in at the beginning, they're doing the same thing. They're showing you the table. And they're getting close to 1 from the left and from the right. So this is getting close to 1. Well, what are these values getting close to? This side's getting close to 4, and so is this one. So the limit from the left and the limit from the right are both approaching 4, which means this equals 4. So if we plug in values, just like we did before, there's one on MyLabs. I think you have to plug in the values and write them in like this one. You're just plugging them in the equation, and you can go to your table, and then you tell them what the limit does. This one looks like it approaches 5. But is there any questions on that? So it's just plugging in like we did in the first problem. Now, sometimes we don't always have a graph to go by when we're looking for a limit. And when that happens, first thing, just plug it in. So when you're finding limits and you have an equation, rule of thumb, first thing, plug it in and see what you get. So if we plug in -1, we get -1 squared plus 2 times -1 plus 3. 2. And we get an answer. So that's it. That's our answer. So if you can plug it in and you get a value, you're done. Okay, so we can plug in 3. 3 squared minus 9 over 3 plus 3. 0 over 6, which is 0. So rule of thumb, when you first get it, plug it in and see. If you get an answer, you're done. The second case, when you plug it in, instead of getting a value, you get 0 over 0. That means that there's common factors. You have to find a way to simplify that. So you simplify the fraction and you plug it in again. Our first problem that we did, the limit as x approaches 2 of x squared minus 4 over x minus 2. If we try that by just plugging in, what happens? We get 0 over 0. That's because there's a common factor in here. So go back and factor. X squared minus 4 will factor into, because it's the difference of squares, x minus 2 and x plus 2. Right? Notice the x minus 2's cancel. So we simplified it. Now we plug in again. When we plug it in again, 2 plus 2 is 4. And that's what we got. Yeah. 4. So we plugged in all these values from the right and left to find it, when we could have just plugged it in, realized we needed to simplify it, and then simplified. So there's a couple different ways of finding limits. One is to plug in values from the right and the left. One is to look at the graph. And another way is plug it in and see what happens and go from there. Let's try another one. The limit as x approaches 3. So go ahead and try this one. When you plugged it in to start with, did you get 0 over 0?
Yes.
I think we do we? 3 squared. Oh yeah, we do. So that means we need to go back and factor this. Now, if your factoring is not as strong as you'd like it to be, one thing we know is because we got 0 over 0, this factor has to be in the top. Because that's what's getting the 0 over 0. So you know that part of it has to be x minus 3. X times, we need an x squared. X times x will give us x squared. And then to get this one, we need a negative 3 times a positive 1. So you can use that to help you factor it. But the other way, you're multiplying to get a -3 and adding to get -2. And that would be -3 and 1. But is there any questions on that? The x minus 3's cancel. Limit as x approaches 3, x plus 1, and then plug your 3 in. 4. Is there any questions on that one? Another one is fractions. The limit as x approaches 0. Okay. So this one is another case when it has fractions within fractions. Notice what happens when you plug in 0. Well, we definitely have 0 in the bottom. Here, this would be a -1/2 plus a half, which then is also 0. So we need to find a way to simplify this. When you have a complex fraction, what you do is you take the parts in your denominator and you multiply everything by them. So we have an x plus 2, a 2, and this is just a 1 in the denominator, so we don't have to worry about using anything here. But if you multiply all 3 terms by x plus 2 times 2, it will get rid of those. So if we have a polynomial on top and bottom, you factor. But when you have these little fractions, you need to get rid of the small fractions within the big fraction. So you have to eliminate the complex fraction. When I multiply these, look at the first one, notice the x plus 2's cancel. They leave -1 times 2 or a -2. Here the 2's cancel and leave a +1 times x plus 2. Now if you wanted to, you could distribute it here. If you do, be careful if this is a minus sign, it has to distribute with it. So it would be +1 times x, which is just positive x, and +1 times 2, which is 2. And then in the bottom, we have 2x times x plus 2. Because there's no fraction, none of this reduces. But leave it factored. You don't need to multiply the bottom out. Any questions on that part?
Why did the x change to x to 2? Or like limit x and then the arrow 2?
I think because I was still putting all my 2's. It should still be a 0.
Oh, okay.
Sorry about that. Thank you. Sure I put them all right. -1 times 2 is a -2. Yeah, okay. Combine your like terms on the top and notice the 2's cancel. So we have the limit as x approaches 0. And we have x over 2x times x plus 2. Now this is all multiplied together, so it's one term, and we have one term on the top. That means we can cancel this x with this one. You cannot go inside here. You'd have to have x plus 2 on top to cancel this one. But these two x's can cancel because this is all multiplied. So we have the limit as x approaches 0 of 1 over 2 times x plus 2. And then you plug your 0 in. So you multiply by your denominators so that these will reduce, combine like terms, and then the common factor will cancel. Then when we plug our 0 in, we have 1 over 2 times 0 plus 2, which is 1/4. Any questions on that one? So the complex is a little bit different. The other one that's also a little different is when there's a square root. We look at the limit as x approaches 36, the square root of x minus 6 over x minus 36. When we plug in 36, do we get 0 over 0?
Yeah.
Because the square root of 36 is 6, and 6 minus 6 is 0. And on the bottom, 36 minus 36 is 0. So that means we need to simplify this. When you have radicals with two terms, in order to reduce them, you multiply by what's called the conjugate. We have the limit, let me write it down here. The conjugate is the same thing, but the opposite middle sign. So it would be the square root of x plus 6. And what you do to the bottom, you have to do to the top. So you have to do it to top and bottom. By multiplying by this conjugate, it will get rid of the middle term. So when it's the conjugate, you only have to multiply the first two and the last two. The rest cancel. So that's one nice thing. But what it does is it gets rid of the radical. So if you multiply by a conjugate, there should not be a radical left. And the only sign you change is the middle one. So when we take the limit as x approaches 36, the square root of x times the square root of x, when you multiply our radical times itself, it just leaves the value. We took the square root of x times the square root of x. It's just x. So multiplying here, square root of x times square root of x is x. Negative 6 times a positive 6 is a negative 36. On the bottom, we're not going to multiply it out. We have the x minus 36 times the square root of x plus 6. So we multiply by the conjugate, which means you don't have to worry about the middle terms. They're going to cancel. You'd have 6 square root of x minus 6 square root of x. Notice that these cancel. Remember, when there's no number, it's a 1. So it leaves a 1 on top. So the x minus 36 is canceled. Left 1 over the square root of x plus 6. Plug in your value. If you plug it in too soon, you're still going to get 0 over 0, and then you know you got to keep reducing. Oops, plug in the 36, the limit will be gone. 1 over the square root of 36 plus 6. Square root of 36 is 6, plus 6 is 12. Any questions on that? Positive. The last case is when we get 0 in the denominator, but not in the numerator. So if we get a number over 0, the limit doesn't exist. Now you still have to state if it goes to positive infinity or negative infinity. So if we look at an example, limit as x approaches -1. X plus 5 over x minus 1. If you plug in the -1, make this a plus sign. That way we want the 0. So change this to a plus sign. That way then we have a number on top, but we have 0 on the bottom. That means the limit does not exist. What's happening is this is getting really large. A small number over a very large number gets close to 0. But in this case, when the bottom gets close to 0, this doesn't exist because it's getting huge. Couple ways you can figure out whether it's positive or negative infinity. I think the easiest one is to graph it. Now you can use Desmos if you want to graph it, or you can use the TI-84. But if we plug this in under y equals x plus 5 and x plus 1. On these ones, I usually use a window of 10 because our limit's -1. As long as it's in your range, it'll work. But I like to use the -10, 10 when I'm finding these ones, unless the limit you're looking for is a really large number. But if you use -10, 10, -10, 10, and hit graph, there's it. Now we can notice that as we look at the limit as x approaches -1, if we go from the right, plus sign, so that means we're on this side. Our graph's going to positive infinity. And if we look at the limit as x approaches -1 from the left, it's going down, because this is where -1 is. Now, if you have a TI-83, it actually puts that horizontal line in there. So that extra solid line you're seeing, that's just the asymptote. But since it's going down, this one would be negative infinity. So from the right and the left, it's going at 2 different spots. Are there any questions on that?
How did you graph that again?
Say that again.
I
Okay,
didn't
graph
graph
got it.
anything. Yeah.
So under y equals, I put the equation. And then for my window, I use negative 10, 10. So anytime you're doing these small ones, as long as this is between negative 10 and 10, you'll see the graph. So I almost always use this. And then hit graph.
Okay, thank you. My window
You're
was
welcome.
messed up.
When you're reading that graph, I still don't get how you got positive and negative infinity.
Okay. So here, let me draw the graph here. I think it'll be a little easier to see. So this is at 0, and then at negative 1, the TI-84 doesn't show the asymptote. But what it's doing is this graph is going like this. And on this side, it's going down. So from the right, should be this side, to negative 1. We're going this way. So we're getting closer and closer to negative 1. This number's getting larger and larger, positively. And so that's why it's positive infinity. Where this one, when we go to the left, it's going down. And so from the left, it's negative infinity. So the limit doesn't exist. There's no bound on it because the y value is getting positively large here. And on the left of negative 1, it's getting negatively large.
All right, thank you.
You're welcome. Any other questions? Okay. We will stop there. Right? 11 to 12. Yeah, that's right. But is there any questions on anything?